I got? No? Okay. If you have seen all of my talks for the last couple of years, then you've seen about half of these slides. So I'm not here to spring anything on you. I'm here to begin trying to cohere some of the observations that I have been sharing and making. And this is very definitely a philosophy track. I'm not going to present any defense techniques. Now, if anybody from my company was here, this is how they would introduce me, as this guy who does things. And what this shows, what this ought to jump out at you is that I have had an outsized influence on human history. What you may not know is that since most of this work was nonprofit, I am nowhere near as wealthy as people expect me to be. This last item, Farsight Security, where I work today, is part of a thread. And I want to let you know, this is how you guys know me. This is different from how how my corporate PR people would like to introduce me. I am that guy who doesn't sleep much and rants a lot. So Farsight came about because of an observation I made, which is we are growing the security industry a lot. We're making a lot of money. New companies making money, old companies making more money, a lot of mergers, a lot of acquisitions, a lot of founders making money, and yet the problem keeps getting worse. And when you see that sort of pattern, if you are a puzzle solver, as I am, you're going to look for what's behind it. In other words, James Taylor famously wrote that distant hands in foreign lands are turning hidden wheels, causing things to come about which no one really feels. And I could see this happening. So at Farsight, I decided to do something about it. And instead of just doing good, I decided to do well by doing good. So it's a commercial company. It turns out nothing that is not profitable will catch on. So I wanted it to be that instead of starting an anti-spam company and getting sued out of existence, we started some sort of a security company that would encourage competition along the same lines and maybe sort of change the flow of history a little bit in our favor. And I want to be very specific here. I live close to Sand Hill Road. It's a street in Menlo Park, California, where most of the venture capitalists in Northern California have their offices. You can really tell that that is a wealthy street. And an internet security company is founded somewhere on that street at least once a day. And every one of them goes out there with instructions to become profitable, become efficient, market dominating, try to get yourself bought for a good multiple, or try to grow up to someday be large enough to buy other people at good multiples. And the fact is, every one of these security companies has the same set of employers. These are the limited partners in the venture capital funds themselves. Those people do not have any particular care about internet security. They care about money. And indeed, every one of these companies behaves in very typical ways. It's very much a cookie-cutter culture. You can almost interchange executives between these companies, and the same buzzwords will fit in the new building just fine. But what is happening is they are all behaving exactly the way the bad guys would most prefer. In other words, the litmus test that caused Farsight's design was, if I were a bad guy and I already owned a couple of banks, so I could already participate in the SWIFT system, and I had another couple of $100 million illicitly gotten dollars to invest, where would I spend them? I would want to be a limited partner in a Silicon Valley venture capital firm, because I want these companies to be as profitable as possible, to be as efficient as possible, to be as competitive as possible. And ideally, that will mean that I, as a bad guy, will have the best possible business conditions going forward, because I will then, let's imagine that I want to commit crime. If you're going to commit a crime, you're going to leave traces in at least two places, the place you launch it from and the place you launch it against. If you could invest in a field in order to make sure that your launch point and your victim were only observed by one company, in other words, no data sharing, that would be your best possible business conditions for committing crimes. You know, least observation, least likelihood of being stopped, identified, predicted. So that is a structural defect. That is something we do to ourselves in order to make our situation worse. Because I don't think there are any bad guys among those limited partners. I think they're just people who invest because they have money and they want to make more. But what happens with that money ends up hurting everybody. And so Farsight has a different attitude. And I'll come back to the venture capital people in a few minutes. So, there are bugs in everything. To the best of our knowledge, there has never been software without bugs that did anything useful, right? Hello World could possibly be bug-free, but anything that does anything useful has bugs. At least it always has. It's possible that someday there will be bug-free software, but even at the cost of tens or hundreds of millions of dollars of QA for the software that goes into space, we still have to send patches to Mars. So I just want to say, if it was possible to get this right, there would be an existence proof by now. The problem is we don't know what the bugs are the day we ship stuff. So why is that? I have some economic theory to share with you on this, and one is that it's competition, right? If you're in the widget business, you want to make one of these, or one of these, or these, or these. You better be in a hurry. You better get your shit together, get it in a box, and get it on a store shelf, or get it into Amazon's catalog as quick as possible, because it will be time to market that dictates the area under the curve of your profit. It will not be the quality of your device. So the competitors who take longer to market or spend more money in order to make a better product are going to lose. You can actually see the losers because their assets are bought after the bankruptcy by the winners. Complexity also creeps in. I call it the entropic heat death of systems in general, because we keep adding layers of indirection or layers of abstraction. We keep combining things in ways that weren't necessarily foreseen, and then we keep creating systems that are greater than our ability to debug them or to understand them. Right, Gotti would not be making any money in the deception field, and there would be no money to be made in red teaming or penetration testing if we understood what we were doing. But we don't. We're building things piece by piece, cable by cable, transistor by transistor, line of code by line of code that gradually outpace our ability to keep track of it all. And then we have to do all kinds of other organic things to deal with what has become an organic problem. And specialization of labor is it's really the root of productivity. As far as any economist ever born knows, this is where it comes from. What this means is you're very good at producing a particular type of software, and then you have to outsource everything else. And all the other stuff is going to have bugs. I got into a conversation at the bar last night about supply chain auditing and the difficulty of doing that, right? You don't necessarily know if there's some appliance or a smart TV or something in your house that still has the bad version of Bash in it, because there was no list of modules and version numbers in the television that you bought. And this is the reason for all that. Tom Furlong, one of the executives at DEC during the time I was there, decided to remap the ADSR curve from early music synthesis into the innovation cycle. This is often presented as an S-curve, but I think this is a better mapping. So if you repurpose the attack, which is where the amplitude is first rising, to mean your time to market, decay becomes the time to your first major competitor, sustain becomes the time to your first, let's say, Chinese or Indian competitor, where they have a very different cost of work than you do, and your release becomes the time to obsolescence, where some other innovator has come up with something, some better widget, some better way to do whatever it is you were doing, so you couldn't sell another unit of your product at no matter what price. You couldn't give it away. The area under the curve measures your lifetime product revenue, and the only thing that you as an innovator have any control over at all is the attack line. The other three portions of this curve are driven by your competitors. And this is why you can't stop to make something good before you get it into the market. And the more of a commodity it is, the more of this type of pressure you're going to see. Often when economic analyses, even something as half-assed as this one, are presented, it's easy to complain, maybe shoot the messenger, whatever. This is not a prediction, this is a measurement. I am not showing you my speedometer, or my accelerator pedal, I'm showing you my speedometer. This is what happens. So we have, generally speaking, two kinds of devices, those that can be patched and those that can't. And you have the devil's choice. If it is patchable, then the mechanism by which it is patched is going to be attacked over and over until some persistent attacker someday gets in. Or your company goes out of business and your keys, the keys that allow those updates to be sent, end up in landfill. Or it's not patched, in which case it will have bugs, because I think I mentioned everything has bugs, and those bugs will be better and better known as the years go by. So there isn't a good third alternative for this, other than maybe give more control to corporations and governments who promise to protect us. So I have had my own various libraries, some DNS related, or utilities forked, where somebody will say, oh, I kind of like this, but I just want to use it as part of something else, or I want to take it in a different direction. And they will ultimately introduce new bugs and fix some bugs, and those bug fixes, there's no incentive, there's no reason for those bug fixes to come back to me. And if I patch them, if let's say they do come back, or I patch them myself, there's no incentive for anybody who grabbed an earlier version of that library to say, oh, my DSL modem product has a bug in it because Vixie was stupid, but he eventually published a patch, I better get that out. No, that's not going to happen. There is not money to be made patching that, so it's not going to happen. So that's code. Let's talk about hardware for a minute. I will get to some philosophy, but I want to make sure that we're on the same page with regard to the scope of the problem. The folks in Ann Arbor came up with a way, I guess they were inspired by Rowhammer, which is a way that chips can be made to behave oddly using analog signals, and they're not meant to behave in an analog fashion. But if you put your memory cells too close together, you can actually leak data between memory cells just because of the physics of the thing. So they were inspired by this to say, well, what if we made some deliberate defect in a chip? Could we then use that as a attack vector? So they took an off-the-shelf, whatever, 32-bit microcontroller system on chip, open source thing that was used by a lot of students to do an awful lot of research projects. They took one of these, they added one capacitor. And the diagrams here from Boing Boing show you, these are from the research paper itself, that show you where on the wafer that capacitor is. And all that you have to do to exercise this particular defect is run a particular data pattern, like 3 successive strings of bits over and over again through a certain register for a certain number of cycles, and that will charge up a capacitor. When it reaches its charge threshold and discharges, it will put the chip into privileged mode. So this was a deliberate defect introduced to prove that it could be done. Generally, if somebody in academia is proving something can be done, then the spooks have been doing it for 10 or 20 years by that time. So anyway, this was kind of eyebrow raising. Everybody said, wow, if it's that easy, it must be pretty common. And of course, you can't actually find that capacitor through X-ray lithography. You have to take acid and take the chip apart in order to find out whether it has this defect. And even there, it is relatively hard to find that capacitor. They're tiny. And that's why Apple and the US military and anybody who actually cares about this kind of thing has a secure fab. Most of us don't. Most of us are just getting whatever we get and building whatever we need to build. So as I said, this was eyebrow raising, but I don't know if you remember when the Equifax break-in happened. That was eyebrow raising, but that had its couple of days of fame and then got replaced by something else, as it was in this case. I am particularly concerned about Intel's response to Meltdown Inspector because they swear on a stack of Bibles that it's not a defect. This is from their website. I didn't make this up. Now, that's probably because of warranty issues. They can't admit that there's a bug because then they would be forced by some class action lawsuit, as I suspect they will be anyway, to fix them all free, as with the FDiv bug. But the fact is, this chip violates the principle of least astonishment. It does something that it was not designed to do, that it was not documented to do, that is pretty damn harmful. And if that's not a bug, which according to their lawyers it is not a bug, then I am really worried about all the other bug-free chips that are in my systems. But we'll come back to the universal persistent aspect of that in a moment. Let's talk about the network. Right? We started with software, now we're talking about hardware. Let's talk about distributed systems. This is a excerpt, it's my own sort of chicken scratch diagram that shows the hell of a handshake vulnerability in TCP, which was not discovered by me. There's, the authors of the paper from Woot 14 are listed here. They are brilliant. I am copying their work. What's happening here is that you're sending a TCP SYN packet on port 80, which pretty much is allowed out by all firewalls and is allowed in by most firewalls because this is the web. This is the RS-232 of the 21st century. This is how you communicate. It doesn't have to be port 80, it just happens. That's common. Anyway, you're sending one of these, but I'm sending it to somebody. I'm sending each of you a TCP SYN packet, and I'm using Sunil's source address, and I'll get to that in a moment. You're all going to answer him between 5 and 50 times. If you're a BSD-based kernel, you'll answer him 5 times. And of course, he can't stop you. There's no message he could send your TCP stack to get you to dislodge this bit of state. If it's a Linux system, which is to say most of them, you'll answer him 50 times instead of 5. This is a bug in the TCP state machine. It doesn't work. You should not have any responsibility to retransmit something until you are in the synchronized state. This is pre-synchronized. Therefore, it is a case where the normal TCP three-way handshake is trying to be set up. It hasn't been set up, so you don't yet have proof that the other guy's source address is valid. He hasn't answered you yet. And I went to the IETF. The authors of this paper went to the IETF. They said, there's a bug in the TCP state machine, and that is pretty much like going to the Catholic Church and saying there is a bug in the 10 Commandments. They're just not willing to change them at this late stage. Now, the thing that makes this seem like a trivial attack is that the packets that you're being bombarded with are coming between 5 and 30 seconds apart. In other words, I'm not causing Sunil in this example to receive all that many packets unless there's, say, 10 million of you or 10 billion of you, in which case the fact that you're each waiting 5 to 30 seconds between retransmissions doesn't help him at all. He's off the net. This is how the internet works. I didn't decide it, and I have tried to change it, so this is pretty much the future. This is why that works. A lot of you have seen this picture in other diagrams or in other slide decks. What's happening here is the attacker, again, is using a victim's source address to send a stream of tiny little request packets to some reflector, in this case a DNS server for .com, which is mammothly over-provisioned in order that it be able to survive a DDoS. And it is answering those questions. And since they're DNSSEC related, it's answering those tiny little requests with much larger packets. And again, the target is receiving all kinds of responses to questions they didn't ask, and there's no message they can send that will shut those people up. This, again, is how the internet works. Rick, can you wait, or has it got to be now? Thank you. I will. So, again, this is a distributed systems issue. It's neither hardware nor software. It has to do with the design of protocols. So Van Jacobson asks that anybody who uses this particular diagram credit him for it. He was brilliant. He was the first person to ever draw a network this way and to get us to understand why congestion control was hard. Later on, Jim Geddes and Dave Tott and some other people realized that if you have a lot of buffering, like megabyte-sized buffers, in your driver, in your chip, in your application, all over the place, then TCP is not, the TCP flow algorithm can't operate because your buffers are a hidden variable and it cannot compute its way around them. And what that means is that in any group like this, where we have hundreds of people trying to use the same Wi-Fi access point, you don't, let's say there was 100 of you, and that you were all pushing the network about equally hard. You'd like it to be that every one of you got your fair share, which is to say 1% of the available bandwidth. But because of this, you're not. You're each getting 1/10,000th of the network instead of 1/100th. In other words, it's 1 over n squared rather than 1 over n. And that is because of these local hidden variables that are built into everything, because who wouldn't want more buffer memory after all? And just trying to get that fixed has taken years because, again, people keep saying this is not a bug. Great. The Morris worm was the first instance I ever saw of return-oriented programming. This was November of 1988. And I was at my desk when the problem happened because I had no family, so I had no reason to go home. And it all came down to this. C is very good at expressing this kind of thing. It's pretty, it's fairly obvious what it's doing, and it does not know the size of the buffer that it's writing into. So somebody connected this bit of code to a TCP IP socket on the finger server and allowed pretty much anybody anywhere to put code on that stack. It's a mystery why this is still in the C standard. They finally took it out of C in 2011. I guess they admitted it was a bug. That surprised us. It's still in C++ though. Now, the fact that we are using a language like this at all, when we have so many transistors and cycles per second and whatnot, is the real mystery, right? We could be writing, most of our stuff could be written in Python or Perl or something, or Go or Rust or something, but no, we're still using this because I guess people are concerned about performance. All right, so by now you're starting to get a sense of where I think the universal bugs are. We users want more features, and we want them soon, and we want them cheap. We're not willing to pay more than we have to. If there's two things and one's cheaper than the other, we will, unless it's an Apple, we will generally buy the cheaper one. We're driving this. And we mostly don't know where our food comes from or where our electronics come from or where our chips came from or what the hidden variables are. We don't know most of this stuff. And increasingly, it is not even possible to know it. It's not a matter of laziness. It's a matter of biology. There are so many hours in the day, and we're using them for whatever we are. But if we used all of our time to try and understand our situation, we would still be ignorant. Which is why I worry a little bit about AI, where we start to let machines design machines that no human ever had any input to, because then we will really never have any hope of understanding what we've done. And I think users, raise your hand if you have never been woken up in the middle of the night by a smoke detector whose battery has finally died. You? Oh, okay. Ah. No fire code where the span lives, right. So for the rest of us, generally you're not at your best at 3 o'clock in the morning, and there's no, you take the battery out, you put a new battery in, no matter what you do, it won't shut up. I have frisbeed these things out windows of my house in order to get back to sleep. And so the annoyance factor does not have to be high to get somebody to really, really get pissy about one of these small devices they've bought. Okay, so I've given sections of this talk all over the world the last 5 years or so, and I have received one reaction more often than any other, And we can't do this. I don't know what the outcome is, but just getting fatigue about how many things we should be worried about that we don't have time to worry about, or fatigue, politically speaking, about the number of things we should be outraged by that, oh God, I'm sorry, I'm still outraged by the things that happened yesterday. This is where we're at, psychologically speaking. This is the turnoff from the highway to hell, that it just means I can't care about this anymore. So, universal persistent bugs is made from us. We are the common element. We build it, we buy it, we sell it, we use it, we operate it. And we're not going to pay attention to any of the lessons of history, not just because every one of us, if we live long enough, become a teenager and have to learn everything the hard way, but because just cussedness of that kind is who humans are. And of course, we only solve the problems we are having. There's no reason to, let's say, create a company that is designed to make the world safer. That's not what the limited partners want to do. That's not going to buy you the big boat you want to buy or whatever. So generally speaking, people do what they're there to do, and then they check out, go do something else. I can't necessarily blame them, or at least if I did, it wouldn't make any difference because we're still going to do it. I had a couple of interesting experiences in raising money for Farsight. One company said, all right, curious about this whole thing about where you sell the raw data and you license it to your competitors and do revenue share on products that they build out of your stuff. If we were to invest in you, we might want to buy you someday, and we would not be doing that. We would have to stop. And I said, well, that's a poison pill defense. If you stop doing that, I won't have any data, so having bought us will not serve you at all. And they said, well, thank you for explaining that so clearly. We're not going to invest. So we basically had to search a long way to find somebody who didn't have a strategic reason for investing, but rather wanted to, do the old thing, which is to buy low and sell high. In other words, make money by having invested. And that was chilling, although it reinforced my belief that we are structurally, we create this problem for ourselves. I had another experience where one of the companies that we were talking to early on about whether or not they might be able to use some of our data in some of their products. Most of our commercial customers are just using it for commercial defense, but we do have some redistributors and derivative works users and so forth. And they said, no, we can't do that because during due diligence in our next round of funding, there's going to be a whole bunch of lawyers looking through all our contracts, and if they see that we have licensed technology like this, they're not going to invest. Now, we drew different lessons, he and I, from that. From my point of view, you shouldn't be working with venture capitalists because they're like that. From his point of view, I can't work with you because you're like that. All right, well, the best thing to do is most likely to think of this as a war, cyber war. This is cyber warfare. And in wars, companies do not compete over military contracts. They are all trying to build as many airplanes or tanks or guns or hats or whatever it is as can be built if it's that kind of war. And the government pretty much tells them you're all going to get paid the same. And the government allows a certain amount of profit to make sure that the industry doesn't collapse. But nevertheless, we don't go against each other when the enemy is out there. I came here yesterday on an airplane. There was a guy sitting next to me who I recognized. He recognized me, but I couldn't remember what company he worked for. And I could not remember, therefore, whether his company thinks that I am a competitor. And so I was supposed to be reviewing a slide deck for one of my people, but I couldn't. I didn't want to open my laptop because I didn't know if the guy sitting to my left was one of the people that I wanted to have know what we were working on at Farsight Security. And that is why we fail. So, I have a few minutes before I get the hook, and questions would be welcome.
Rick, you had a question?
Paul, excellent presentation. On your TCP/80 slide, you said that you had approached the IETF and wanted to make some revisions to some early RFCs. What were the proposals? You didn't go into them. I was hoping to hear about what you guys.
There's only one proposal. There's only one way to fix this. Right now, any data that has a sequence number that has been transmitted, that has not been acknowledged, has to be retransmitted. And that includes the sort of virtual sequence number of the SYN-ACK, right? The SYN character, or the SYN symbol, takes one unit of sequence space. It has a sequence number. So if you send a SYN packet, clearly the SYN had a sequence number. You as the sender are going to be retransmitting it. If you don't get an answer to your SYN, you're going to send it again anyway. There's no reason to ever retransmit the SYN-ACK, because if you didn't get it, you're going to send another SYN. Nevertheless, the SYN-ACK must also be ACKed. And because they're not getting an ACK, they have to keep sending the SYN-ACK. And all we need to do is make one tiny little change, add one diamond-shaped box to the TCP flowchart that says, if you're thinking about sending an ACK and you're not synchronized, don't. Nobody has been able to come up with a case where that breaks anything. Even the thing that nobody ever uses but is often the corner case used to reject proposals, which is simultaneous open, continues to work even with that change. And so nobody has been able to find a reason not to do it, except that it's a really old part of the scriptures and nobody wants to touch it.
I had a question. Did anyone else have one? So your last point is, I think, the most poignant point, which is in wartime, we should not compete against, in wartime, those who are trying to defend the nation, defend our way of life, should not be competing against each other. And I'm kind of massaging the words a little bit here.
Well, thank you for misstating it slightly so that I can clarify what I meant. I expect competition. Competition is necessary because otherwise we're going to build the wrong thing. So it is a very important cohering function for innovation. But what I'm expecting is relatively friendly competition, more like the way Japanese conglomerates work together, all build something similar, and everybody knows that everybody's going to get a piece of the action. That's fine. I'm totally fine with that. And I'm also fine with losing if you're building something nobody wants. But I'm in this odd situation where I did a few things and got famous and could be working anywhere, but I chose this. And the reason I chose this is that although I don't know what day it is, I know that someday I will die. And I have a finite supply of days. I'm not going to spend any of them doing something that somebody else could be doing. I got to find something that only I could succeed at. And that's hard, but we're doing it. Believe me, nobody, I'm not sure if we will succeed, but I know no one else would succeed doing what we're doing. I like that. But it also means I tend to create new market segments rather than competing in existing ones. But when we are doing product research, when we're trying to figure out what to build next, to the extent that I'm asking any of you what you're working on, to the extent I'm looking at your websites trying to figure out what you're succeeding at, it is not because I want your revenue. It's because I want to make sure I don't waste my time duplicating the effort you've already put in. Whereas I have got companies who treat our releases as their roadmap because they assume that whatever we're doing is going to be big someday. That's not friendly, and that's not helpful. There is plenty of business for all of us, even if we were cooperating with each other. We don't need to cannibalize each other. A year ago, I stood in the other room and I said, the Palo Alto Network's CFO had made a very disturbing comment during the recent earnings call, Q4 earnings call. He said, we're doing very well because we are successfully taking market share from our competitors. Boy, I really needed everything Palo Alto Networks could do and everything that competitor could do. I needed them all working as hard as they could to make us all safer. And cannibalizing revenue from each other does not do that. It is a waste of time. and it will ultimately cause distraction, loss, waste. It's the opposite of a solution to any of the problems that we're having. They've got to find some way to put every transistor and every dollar that we have in service of making us safer, or we're going to keep losing.
I have so to clarify what I was going to say in relation to Paul, I have made public statements stating that I will not buy from a company that competes in the wrong way. And I could not precisely characterize what I meant by that in terms of there's good competition, there's bad competition. And I think it's helpful to understand, or to have a framework for us to say, look, we're okay to compete, for you guys to compete in really what is blue ocean type of opportunities. But if you're trying to grab market share from some other vendor that's doing exactly the same thing, then please don't waste my time. Go find the next problem and solve that for me instead.
Oh, thank you for that.
So I'm of the opinion that there is a state of equilibrium within the security industry, right? And with all the threats coming at us and the defenses we're throwing at the threats and all that, that the state of security is not going to get any better than it is today. There's always going to be an uphill challenge for the defenders. The adversaries are always going to have an advantage and so on. And in my opinion, some of that manifests and connects with what you just said about the stealing the revenue. There is a fixed amount of dollars that organizations will spend or are able to spend to mitigate those risks. And to me, that kind of goes to the Palo Alto comment about, well, there's only $100 million or $1 billion in this market that we have to capture all of that and to be the most successful. I don't see how that's ever going to change. And so for the survival of the fittest in the market, that's the way it is. So would you agree or no?
So I want to say, before I say whether I agree, that your vision where we are at an equilibrium would be pretty cool. Instead of everything getting worse and no end in sight. So if it could just stop getting worse, I would say that we had won the first of some important battles. Well, so the fact that it's getting worse almost invalidates the question. And yes, it's inevitable that people will come and try to. And when I say that humans are the universal persistent bug, and the part of that is that they solve the problem they have. Well, the problem most of us have is not enough revenue, and so that's what we're trying to do. And if we do that in a zero-sum way, where we take market share, that still solves our problem. We still have growth. The limited partners who invested in the VC, who invested in us, are going to do well if we do that, and we get to do it again someday, or get a bigger boat or something. That's the problem we have. That's the problem we're going to solve. So in that sense, I agree with you. It's inevitable that we're going to keep doing this. On the other hand, Sunil described a position that he's taken as a IT security buyer, which I don't think would harm the market at all if a lot more people took it, but it would certainly cause a lot of this cannibalistic behavior to stop. I really would like it to be that I could sit down with any one of you and tell you what I'm working on, and you would find some way to benefit from it that didn't hurt me, or some way that we could work together that would help us both, or something. But I can't, and you know I can't, and you can't either. And if we don't solve that problem, there's going to be all kinds of cooperation that we don't do, and things are going to continue to get worse. So my answer is no. I have a history of upsetting apple carts. I did not like the status quo 4 or 5 times now and changed it, and I'm going to do it again.
So what we're talking around is actually the scarcity versus, this is Jesse, the scarcity versus abundance philosophy. And many vendors in any field, especially in security, do look at the scarcity model. There's only X number of dollars available. Well, my personal direct experience is that that's not true. You can talk to a lot of companies, they say, well, we only have $1.35 million for this. But if you give them a good reason, that there's a cost-benefit analysis, based on cost-benefit analysis of what their business value of what they're going to be spending, they might have, well, maybe we actually have 1.63 or whatever, right? So these things happen over time, and sometimes too many companies in every industry looks at the next quarter, the next quarter, the next quarter, and so they look at today's sale and today's sale and today's sale, instead of looking at how can I improve your business by improving, how can I improve my business by improving your business? And how can I work with your business to make better value out of the other investments and sunk costs you've already have? That's the abundance model. How can we all grow together? But the industry as a whole looks at it as the way it's been discussed. That doesn't exist. We have to take market share from somebody else. Screw it. There's always going to be more problems. There's always going to be more money. Let's just grow market share.
Well,
look for Apple.
So I agree with you, and I want to say it's not a question of philosophic outlook. You don't decide in advance whether it's scarcity or abundance and then accord yourself. Gartner famously, in the fourth quarter of 2016, said that the cybersecurity market was worth 70 billion, that's like million but with a B, and that by 2020 it would double to $140 billion. It's already doubled, so they were way off the mark. So no, we are not dealing with some kind of a fixed number of dollars and we just have to keep moving them around. However, the easiest sale to make is to a qualified lead. And there is no lead more qualified than somebody who's already paying for what you're selling, but they're not paying you yet. That's the easiest thing to do. So what we're dealing with here is some combination of laziness and greed, which is also part of the human equation, because you solve the problem you have. I want to point out, I'm the last thing standing between us and a party where there will be beer, and I slept in, so I'll be at the party.
All right. With that, thank you very much, Paul. Very thought-provoking comments. So Eleanor is where the party's at. It's going to start, I think, at 5:30, actually, so pretty soon. So a couple blocks over. And stay tuned. I'm going to send out emails or on the Slack channel what we should expect for the philosophy track tomorrow, okay? So stay tuned for that. We're going to deep dive into a couple topics that we covered today. So thanks very much.